Okay, and today is the 14th? 17th? Oh, holy cow, how did that happen? That's ridiculous. 11717. Okay, so in an ionic compound, remember we have this very careful lining up of charges, and that means if you hit it with a hammer, these things are now misaligned, and they actually have a repulsive force between them, so it just flies apart, they shatter, they tend to be very brittle. Where in a metal, we have what's called what's metallic bonding often called? The come with me to the sea. No? Honey dippers? No. Sea of electrons? Remember that? Does that ring a bell? Faint, dim, distant bell. I'm huffing my scarf again. I'm sorry. Okay, so in a metal, we have those bonds running in all directions. This is profoundly astounding to me. I'm serious. This is weird, freaky stuff. The way materials behave at the macro level that we can see, the fact that I can bend that wire, is because of how their actual atoms are arranged. The way their atoms are arranged is reflected up at this macro level in how the material behaves. So this stuff, bend it, push it, move it, doesn't matter. You've got free-flowing, delocalized, they're not tied to one spot, electrons that, okay, you want to push this way? Sure, we'll push that way. And they continue to have those strong bonds of attraction throughout because they're all spread out. Versus something rigid like this where you can't move it. There's no flexibility. Molecular compounds, of course, kind of fall in a different area altogether. And that is that they have, whoops, we'll get rid of that altogether. They have incredibly strong internal bonds because they're actually interlocked. They're holding hands, they're locked together. But between one bond of this stuff, and I don't even know what I've just drawn, it's some kind of propyl compound, and another bond of this stuff, yeah, they slide right past one another. No big attraction from one to the other. They're kind of operating in their own little universes. So, sort of within the boundary of that electron cloud, powerful forces, very hard to break apart. Between two of them, they move side by side easily. And whatever this is, it would probably be a gas at room temperature. It's a little bit like propane. Maybe it's a propene. It's some kind of 3-carbon compound. But this is a molecular substance. And so the bonds internally to the molecule tend to be very strong. The bonds between molecules tend to be pretty weak. So they tend to have lower melting points. Does that help you with your lab?